Hello. Wait a minute. Oh, sorry. Hello. Sorry, I'm late. Hello, Nasreen. Hello, Colin. Hello, Brandon. Hello, Alexis. Hello, Mickey. Awesome. Hello, Anissa. Hello, Ariana. Hello, Maria. And now there's chat happening. Give me a sec. I'm a little bit behind here. I apologize. Hold on. Good morning, direct chat person. Good morning, Maria. Good morning, Ariana. Good morning, Nasreen. Good morning, Chanel. Good morning, Brittany. Good morning, Anissa. Morning, direct chat person. Good morning, Carolina. Good morning, Brandon. Good morning, Ryan. Okay, who else am I missing? Good morning, Brittany. Good morning, Xavier. Good morning. All right. Good morning, Alexis. Is that and more people coming? All right, hold on a second. And also, okay, I apologize. Give me a second because I see that I have done a couple of things wrong already. Oh, for heaven's sake. Hang on, bear with me. But what? Hold on. Oh, sorry, I am here. What in the name of Nebuchadnezzar? Why am I not? Okay, hang on. So sorry. Things happening. Things actually not happening. Bear with me. I am, and please bear with me because I'm trying to fix something on your Google Classroom, so I'm not looking at the screen. So if something is happening in the chat, I don't know it yet. We will. Are you kidding me? Oh, and more people, and there's people in the waiting room. I see that. Well, I don't actually see it, but I gather it. Okay. Okay. Sorry, bear with me. Letting the people that are in the waiting room. We're almost there, I believe. Oh, it's still Oh, yes, someone's there. I know. Okay. Uh-huh. Okay, I apologize. I apologize. I think we're ready to go. By we, I mean me. I mean you are obviously ready to go. Although, wait, I'm lying. Just There is one other issue, but I think we'll live with it. All right. Okay. Apologize for that. So hello, let me just see the chat if I miss anything. Um, right. Good morning, Anissa. Good morning, direct chat person. Good morning, Carolina. Good morning, Brandon. Good morning, Ryan. I guess I did say that already. All right. Welcome, Emily. Welcome, Maria. Anybody else who I didn't say? Gaia, Chanel, Stephanie, Carolina. Whoa, that is scary. Charlene, good morning. Good morning. Adenelsi, good morning. Okay. Thank you. And thank you, those of you who are showing video and all that. All right. Yes, let's just get going. I apologize for all of that shenanigans. Although, let me pause. Like, yes, I'm ready to go, but let me pause. Are there any questions at all about? I mean, we're going to go back to the physics now. Like, I'm going to continue walking through the homework one. I'm going to walk through it a little faster than Monday. Like, I'm going to focus more on the physics than on the method of showing steps. But but before I do, are there any questions at all about anything I said yesterday or about how the class works? Or physics or any. I'm just looking at it. No, we're good. That's Colin saying we're good, I think. Okay, we're good. Nasreen's indicating that we're good. Yes. Oh, thank you, Judith. Oh, that's an answer. That's points right there. Thank you, Judith. All right. So that's a please go forward right there. Okay. So I'm going to get back into going over the homework one, right? And homework one was number line. Um, um, okay, just to be super clear, if you're watching this later, like or looking at the PDF later to help you to do the homework. What I'm going to do now is start really talking about the physics that's going on. So I'm not necessarily doing all the steps when I'm teaching, like for efficiency's sake. I still want it to be clear. So you can use all of anything I say. If you got anything wrong in the homework or you didn't understand something in the homework, you can use all this to go back and revise the homework and rehand it in and get all the points. That is totally legal. But you just have to understand that you still have to do all the steps, show all the steps to get all the points, even if I'm not showing them here. Okay, I hope that's clear. By the way, someone asked me also, can you use like old videos to help you do the homework or to get ahead in the homework? Absolutely. I mean, of course, yes. And you can use anything on the web and your friends. You can even make friends and then use them. I don't use them, but use them for help. So yeah. But I just always want to be clear, like your responsibility in the homework is to show all the five steps every time. That's partly like how you're showing that you actually understand. So even if I don't here, that's because I'm trying to emphasize something else. Okay. Oh wait, oh, that's interesting. Sure. Question in the chat. Okay. So yes, what I call them is the five-step method for solving physics problems, the five-step method for solving physics problems. And if you're ever looking up old videos of mine, certainly you could type, or anything like that, you could type in five-step method or something. And for sure, the five-step method for solving physics problems is there's at least one sheet, and there will be more sheets about it in the tools section of your Google Classroom. But as far as searching it up like anywhere else on the internet or like Khan Academy or something, again, that would not be cheating at all. But I mean, to be honest, like yet nobody else calls it that. It I mean, it's a me thing. Okay, I mean, you're not going to find it anywhere else. That doesn't mean it isn't super real. I mean, this is like a little dicey. I'm promising you from 30 years of experience of teaching and from going to graduate school twice, like if you do the five steps, it is a distillation of what all other physicists do or all other physics professors expect, or it is. I really believe the key to unlocking hard physics problems, but you're right, I made it up. So I mean, I didn't make it up. You know what I'm saying? I distilled it down to 5 steps like this for you. So you're not actually, for good or for bad. So you're not going to find it anywhere else exactly in that form. Um, and like I made up the acronyms and whatever. I hope that doesn't make it any less legitimate in your mind, but um, right, you're not going to find it other. I mean, if you do, I'd love to hear about it. That'd be great. But okay, so that's just the honest answer to that question. Or I think that's what that question meant. Um, right, I made it up as like a way of memory, like the acronyms and stuff. Like, but I'm promising you, I'm not making up the ideas. Um, okay, but good question. Any other? Sorry. Okay, I'm looking in the chat. Is there? Oh yeah. So all right. So let me quickly. All right. So in the direct chat, someone's asking, is it like written in a separate document in the Google Classroom? And can it be so we have something physical to look back to? I mean, that's a totally reasonable question, but totally reasonable. But the answer is yes. I'll quickly screen share just so you can see. And I'll also, hold on one sec. Totally fair. Hold on. Okay. So I'm going to switch screens for a second. Okay, so if you go to your Google Classroom and you scroll down like past all the homeworks like this, right? And past exams, which of course we'll talk about as we get closer to there. Although please notice like the midterm exam from last year and the final exam from last year are posted there already as a reference guide or as like a practice test or whatever. I mean, you can look at them at any time. So just as a sidebar, getting old materials from this class is not cheating. I'm putting old materials right there for you to save you hassle and to indicate like anyway, whatever. So if you scroll past exams to tools, okay, you'll see right here under tools the 5-step method. And so the summary of it is right. It's a one-page summary right here, written in my handwriting, but that summarizes the whole thing so you can remember. But also, I will tell you, so I hope that wasn't too quick, but it's right there in tools. And obviously, you can replay the first video from the first class too, etc. But the other thing, as long as someone's asking, because it is important, because again, yes, even if I sort of, I mean, I made up a lot, like at this point in my, I mean, for good or for bad, even if you can't find it like this in other places that aren't me, I will also say, like, we use it for 2 semesters, right? On everything uh, for your work and for my grading of your work through the homework and through the exam. So yeah, it's worth knowing. And as we proceed through the semesters under tools, I will put more examples of problems solved step by step by this method so you can see examples of what I mean. And you could put them there too, because just so you know, if you notice under the game thing, one of the portals, so right, these are all the game portals, right? That hopefully are getting more and more the participation game. It's hopefully getting more clear to you. One of the portals somewhere, yeah, is user manual, the 5-step method for solving problems. The minute any one of you feels like you get it, if you've gotten a homework back where you did a problem according to the 5 step and you feel like you knew what you were doing and like you got full credit for it, whatever, you can crop that and put it in and deposit it in this portal, and or just make your, people have done this in the past, just make your own, like a guide, like for your colleagues. Just say like, this is how the 5-step method works in words that are clearer than Yaverbaum's words. Like step 1 is DFP. Here's what I mean. Draw a diagram, blah. If you make an example of the 5-step method that you think would be helpful for other people, you put it here in user manual of the 5-step method, and you'll get extra points for doing that. And then I will put that example into the tools so that other people can see. Okay, so we'll all get more and more used to, but right now where you look is tools, like I just said, like under here. Okay, hopefully that's sort of clear. It's certainly a fair, good question. Wait, is that, I'm just looking back in the chat to see if that's clear. Uh, okay, yeah, no, and thank you, person who just asked that. I totally am with you. Oh, great. And thank you for saying thank you. And again, no, I mean it was direct chat, right? So I'm not going to say who it was, but please, the person who just asked that question in the direct chat, again, I cannot emphasize enough what a fair question it is. And he or she can now deposit for a bunch of different points just for that question. Just to be clear again, right? She or he can deposit that question in the please go back portal because I was like mentioning the 5-step method, but then I was blasting on. So even if you think that you didn't need to hear that, like whoever you are, that person did. So they can put in the portal, please go back and get points for that. And and when I was done, that person in the chat wrote like thank you, like in a polite, enthusiastic way, and wrote, which basically indicates now I can go on, right? So they can also put the exact same screenshot of that chat in the portal that says closing a conversational loop, because even though I haven't yet, because now I can go on, right? So they can double dip that for participation in two different places, and frankly, even triple dip it if they even want to put it in please go forward now because they said thank you. So that means like, okay, just so it applies to all of you. Okay, I think you get it. So thank you. Okay. And yes, visual, uh, I totally can relate. Okay. So I'm gonna go back to the hopefully that's clear. I'm gonna go back to the other screen. Wait, how am I going back to the other screen? Ah, did it again. Sorry. Okay. Okay. So I believe we were, tell me, I believe we did question one. Well, right. We did question one. Could someone tell me in the chat? I don't remember if we did question two. Are we on question two now? Oh, we did question two, right? The displacement. Like I'm basically saying, I think the answer to question one, stop me if this is two. I think the answer to question one was the distance equals 21 feet. And the answer to question two is the displacement for the whole journey equals -9 feet. Are we? Oh, now we're on question two. Oh, okay. Oh, okay. Thank you. Thank you. Yes, that's right. Okay. I see in the chat. Okay. Okay. So great. That's how far we got. Okay. Okay. So 21 feet, -9 feet for the question two. Oh, okay. Just right. Okay. So notice they're both important concepts, distance and displacement, right? They're both important concepts, but one is more sophisticated than the other. Displacement is distance and direction, right? Dis- Displacement is an example of what we call a vector quantity. And distance is an example of what we call a scalar quantity. Okay, vector quantities are quantities that include both magnitude and direction. Scalar quantities do not. Scalar quantities are just pure magnitudes. Okay, so temperature is an example of a scalar quantity. Mass is an example of a scalar quantity. And there's no like vector version of either one of those uh, quantities. But like distance is an example of a scalar quantity, and the vector version of it is displacement, right? And notice before I go on that displacement is a richer, sort of larger concept. Displacement includes the idea of distance, like plus the idea of direction. So you can say that distance is the magnitude of the vector quantity displacement. Like that's how we talk about it. Distance is the size piece of the information package that we call displacement. Similarly, there's a word called speed, right, which we're like about to get into. There's a word called speed. Well, speed is a scalar quantity, but what speed is the magnitude of the vector quantity known as velocity. Velocity means speed and direction. Okay. And again, I know many of you know this from high school or whatever, but I'm just sort of reviewing it or getting it straight. So, um, so we need, although the scalar quantities do matter in physics, again, the scalar quantities often are pieces of the vector quantities, but excuse me, but the vector quantities are more sophisticated, and ultimately physics is about space and time, or motion through space and time. So ultimately, we absolutely need to keep track of direction in physics. So we start developing notation, symbols, mathematical abbreviations, and so forth for these quantities, particularly for these vector quantities. So I want to shift. Of course, I'm going to get the rest of the answers on the sheet in a moment, but I want to shift and start establishing the mathematical notation, the symbols and stuff that we use to capture all of this, i.e., we have to start getting into equations, as you can imagine. The one reason I take 2 days before we even get into the equations or the symbols is I want to emphasize that all the equations are just that. They are symbolic expressions, symbolic abbreviations of any and all ideas that we care about in physics that we can first and foremost express and think about in our native language. Like, I want you to understand that when we shift to things that start looking more and more mathematical, it's just a more efficient way of writing down the stuff that we should be able to think through and believe in English or Arabic or Hebrew or Chinese or whatever, right? Like for real. Like the math is just an abbreviation for thoughts that we want ultimately to make sense. So none of it should just be raw memorization or raw acceptance on faith just because it looks like math. Okay, it's a translation, is what I'm saying. So that said, um, that said, okay. So I'm about to start defining some terms and giving you symbols that, again, many of you have seen in high school. It's not going to be, like out of nowhere, but just so that we're all clearly on the same page. Um, and kind of like, because I was moved by the direct chat question about the Like, where can I look this up visually? So just so you know, this topic that we're doing, this homework that we're doing, homework one, where the person's going back and forth like on a number line at the front of the room. Okay, so again, like, I mean, that's just a homework problem that like I just made up years ago. There's nothing, that's not like the standard, but well, that's just a problem in our class. But it does represent a standard problem that introduces us to the standard chapter or topic of physics known as 1D kinematics. Like, in other words, if you did want to look up any of this stuff that we're about to talk about now, anything that I'm about to teach right now, if you wanted to look this up, in our optional textbook or in Khan Academy, or or I shouldn't be, I'm not trying, this is not a paid advertisement, I'm just saying, if you wanted to look this up in any standard place in the web or whatever, yeah, the chapter that we're doing is 1D kinematics. That is a standard term. In our textbook it's chapter 2. um and kinematics means motion. Kinematics means motion, but all of physics is about motion. Everything we do in physics from here on in is about stuff moving through space and time. Like, literally, like, stuff moving through space and time, as in kilograms moving through meters and seconds. That's all of what physics is, as complicated as it might ever look. That is what it's all about, is predicting where something will be when. Or, well, let me say that again. Like, that's what physics is about: predicting the future, predicting where something will be when, right? Or if you're at John Jay, right? If you are going into criminalistics or forensics of any kind, if you are going into a crime solving arena of life, which many of you are, and you're maybe even wondering, why the heck do I have to take physics to like solve crimes? Well, the answer is because physics is not, it's just as much about retrodicting the past. Physics is about where something was when. Like, if a bullet is here now, where was the bullet 5 minutes ago? Or where did the bullet come from 5 minutes ago? You get what I'm saying? Physics is about predicting the future or figuring out the past of where things are in space and time. That's what physics is in general. Kinematics, the chapter called kinematics in any textbook or on or web page or whatever, kinematics, even though it technically means motion, what it specifically means is defining the terms of motion, which we have to do now to do physics, right? And specifically, this homework problem that we're analyzing is our first glimpse at looking at things through moving through space and time. And it's the simplest possible first look we could take. We are first just looking. The reason it's like a problem about a number line is we are specifically first looking at an object moving back and forth in one axis of space while one axis of time ticks on, right? We're reducing our focus. I mean, we're focusing in on one axis of space and one axis of time, not because we're lying to ourselves. We're not saying that other axes of space don't exist or something, and we're not saying that we're stupid and we can only handle one. We're saying we're going to look at one dimension at a time. That's how physics works. Like, you start with this one variable, you look at it and then you add another variable, and then you add another. Okay, so we're looking at one dimension of space in one dimension of time. Um, so one um, luxury that we gain if we're just in one dimension. Another a physics term for a dimension of space is a degree of freedom. One dimension in space is one degree of freedom, meaning at any given moment, you have one set of alternatives from which to choose when you're choosing your direction. You could go forward or you could go backward. There's no other way you could go, or you could use other words. You could go left or you could go right. There's no other ways you could go, right? Whatever, north or south, no other ways you can go. One degree of freedom. Therefore, the whole concept of direction at this point in our physics analysis, the whole concept of direction can be captured with just plus versus minus, right? As I'm sure most of you could tell. And plus versus minus are up to you to decide once you decide where zero is. We're going to get more and more into this, but once we establish this number line, you, the researcher, the physicist, the problem solver, you will make a choice. Where is zero in this universe? And then you make a choice. Is everything to the right of zero called positive, or is everything to the left of zero called yeah, and then you label that choice and then you stick with it. That's one of the reasons we always put a diagram first, is because it's up. You'll see more and more, it's up to the perspective of the problem solver to decide what positive means and what negative means. But once they decide, then they have to be consistent with that. Okay. From now on. Okay, so we're just trying to establish notation. So from here on in, when we use X, so obviously, again, the point of today's class, I will get back to the questions in the homework, but I want to start actually showing my work with like symbols and equations. So, right, so I'm pausing right now first to establish what the symbols mean. And again, it's not meant to, I know it's not terribly exciting. It's not meant to like blow your mind. You've seen these before, but it is meant to be clear or clarifying. Also, I want you to notice one of the reasons I'm like stopping to like literally spell out this is what we mean by X from now on. This is what we mean by T. When I put them together into an equation, this is what we mean by that equation. Part of the reason I'm like spelling it out, even for those of you who already know it, the reason I'm spelling it out is because I also want to establish a precedent or a pattern that like we can only use things from here on in that we have established. Like, yeah, like for me, when I'm going to use equations to show you my solutions to the homeworks, I'm only going to use equations that have somehow first been established in the class. right? And that's also partly why we say like step three is general definitions and principles. That, as far as I'm concerned, always means a general definition and principle that came from the class. And if it comes from the class, what I'm hoping that you see, especially if you, and I don't mean this defensively, but say you're like at all bored with what I'm about to do and you like think it's like easy and like not, not terribly challenging. Well, that's a good thing because part of what I'm trying to show is no matter how crazy physics eventually looks, everything is supposed to come logically from something that at some point made so much sense to all of us that we actually pretty much think we already were thinking that. We just weren't thinking it in the same symbols, like we already knew it, but we just didn't care or something. Physics is supposed to make sense. It is supposed to be a set of logical inferences from things that we already believe or would accept, right? So if at the beginning of the class, if the beginning of this class seems like I'm going sort of slow, like to some of you, I am, but it's not to condescend to you. It's to show like the grounding of everything in physics is something we can all hopefully accept and find totally self-evident. And then we build and build and build. But nothing that I say to solve like a homework question or an exam, I should never use an equation that's just like out of left field that I just say now just like memorize this because some expert once came up with it and we all, follow that authority. It's not authority. It's logic, right? Okay. So similarly, you're not supposed to just like put an equation down or something in the homework that just came from nowhere. You get my point. Okay. So I mean, I think you get my point. Or can I go back real quick? Oh, sorry. Wait, yes. Oh my God, that was like 13 minutes ago. I'm so sorry. Uh, is that Judith? And thank you for, okay, thank you. But is that what you wanted or another page? Or is it too late? One more page. Okay. Yeah. No, thank you. Okay. Yes. I'm glad. That's also points. She totally should submit for points for please go back. And there should also be a portal for like patience. Okay. So tell me, oh, one more page again. Okay. Sorry. Got it. Okay. Cool. No, thank you. No, I'm sure that helped somebody else too. Okay. Um, right. Okay. So that's that, then that, then that. And that, okay. So now, and again, also, I know I'm always like defensive at the beginning of the, just so you know too, because I do think at some point physics starts to get hard, or for some of us. Well, no, for all of us, at some point physics gets hard. Otherwise, it's not worth doing. But and I don't want it to be. It just sort of so what I'm trying to say is I promise the class goes faster and faster as we go. It for good or for bad. I promise it goes faster and faster as we go. But here we go. All right. So from now on, I'm going to use X to mean a point in space, or in other words, a point in space, like the 4 meter mark. X equals the 4 meter mark, or the -7 meter mark, whatever. A X from now on will stand for a value of location of a point in space, which we otherwise call a position. Okay. T, lowercase t, will stand for a point in time, or what we otherwise call an instant, right? Sidebar, I'm saying X as long as we're in one dimension. I could just as easily say Y, if we wanted to view the dimension as vertical or something like that. And of course, eventually we're going to have more than one dimension in our life. So it will be X and Y and Z or something. But letters like that are what we use to mean position. T is what we always use to mean time. So these are like what become independent variables, right? Then I want to say, notice already, I'm using a notation that might be unfamiliar to some of you. A very important piece of notation in physics and math is if I use a triple equal sign from now on, that means equal by definition. Whereas, and that's an important distinction. If I just use a double equal sign, I mean equal by discovery or inference. Like we figured out that two things are equal. But triple equal sign means that we established that two things are equal. Frequently, step 3, GDP of your problem solving, frequently that will involve triple equal signs. Like you'll know you're doing something right, probably, if what you're writing down in a step 3 is a triple equal sign. And then frequently what's happening in step 4 is, in a way, you're converting triple equal signs into, you're eventually landing on double equal signs. Like by the time you get to a discovered answer, it'll be a double equal sign. Why this is an important distinction? I mean, it really will help clarify a lot of ideas in physics. One reason it's important is, just notice, anything that's true by definition is always true. Right? I mean, a triple equal sign is a stronger form of equality in a way than a double equal sign. If something is true by definition, then it's never not true. I mean, you're not going to find a 5-sided square, if you know what I mean. It doesn't, and if I, right, you know what I'm saying. But similar at the same time, triple equal signs are always true for kind of circular reasoning. I mean, they're only true because they're just abbreviations. We're just saying a square is a 4-sided figure. No one figured that out in the lab. It's never going to be wrong that a square is a 4-sided figure, but it's right because we're just saying, instead of saying 4-sided figure all the time, we want to save our breath and just use the word square. So we didn't like really advance our knowledge. We just abbreviated our language when we so triple equal signs have advantages and disadvantages. Same with double equal signs, and it's really important to keep them straight. Okay, so okay, stop me if I'm. Oh, sorry. Why is there a blank? Oh, yeah. Oh, good. You guys really are paying attention. Thank you, direct chat person. Sorry, the blank space. When I do that, if I lined it up, so someone's asking, I'm sorry, someone's asking in direct chat, like, why is there a blank space right before position, right before instant? Yeah, that's just, I don't, that, if I line up equal signs like that and leave a blank space, that is like a standard physics way of just saying, I'm, that it's, the second equal sign is another thing that the X is equal to. In other words, that's an abbreviation. I could have just done this. Sorry, I don't know if that makes sense, but yeah, it's just another way of saying, it's like saying X equals point in space, but in other words, it also equals position. So I don't know if that, okay, thanks. Great question. Great. You're definitely paying attention. All right, so X from now on means your spot on the number line, and T is your spot in time. They are spots, they're points, right? So then we go a little further and we say, okay, from now on, okay. So now, oh, and sorry. Okay. So now this may be new to some of you, may not. From here on in, if I ever put a subscript 0 to the right of X, so I'm going to read this out of order now. If I ever do that, if I put X sub 0, we don't read it out loud as X sub 0. The way all physicists will read it, will read out loud the symbol, they'll say X naught. Like naught, the word naught, like means nothing in British. Okay, so and it's also sometimes it's spelled with a O rather than an A, but naught means nothing. So if you see X sub 0, you read it as X naught. And what that means by definition is the value of x when the value of t is 0. That's what it means, like always. That's always what it means. In other words, in English, it means the very first value of x. Okay, so x naught, it does not necessarily equal the value 0. It equals the value of x whenever the value of t is 0. So, for example, in homework 1, right, when like from the moment the clock started on this thought experiment, from the moment we were paying attention and started our stopwatches, we noticed that the instructor at the front of the room was already at a spot that we call 4 meters, the 4 meter mark, right? So the value of x naught in that case, I mean, soon when I go back to solving the problems, you'll see like x naught for that homework problem equaled +4. And stop me if you don't follow it. I'm looking at the chat. Okay. Okay, so that's from now on, x naught means the very first value of x, which may or may not be 0. And you see what I'm saying. X naught does not necessarily equal 0. When I put the 3 equal signs and then the line through it, I'm not saying x never equals 0. I'm not saying x can't. I'm just saying it, by definition, it doesn't equal 0. I think you follow me. Now, then I'm going a step further. And I have this weird symbol there. Like, what is that squiggly symbol? You can put whatever you want in your notes. The weird squiggly symbol, I'm trying to say, from now on, anything in physics, if we put a 0 next to it like this, then it's that thing naught. It's the value of that. So from now on, any measurable variable that we would ever track in physics, if we put a 0 next to it, we mean the first value of that variable. I mean, for example, I think something just happened in the chat. I will look in 1 second. Sorry, I'll just finish the sentence. If in a few minutes we're going to define v to mean velocity, right? Then from now on, it's understood. If you put v sub 0, you read that as v naught, and you would mean the value of velocity when t equals 0. That's what we're saying from now on. Okay, wait, chat. X naught, yeah. Oh, yeah, yeah. Oh, wow. Oh, wow. Oh, okay. Yeah. So great. Oh my God. All right. Wait, that's awesome. So great question, Judith. And sorry, my handwriting is like terrible. But I hope you guys realize it's so great that others of you answered her chat. And I mean, thank you, Carolina, and thank you, Heart One, whatever. Again, not to, I won't drag this out, but we're all new to each other. So I want to make it super clear. First of all, that's awesome. Thank you, class, for being a class. But second of all, like specifically now, Carolina and Judith and whoever put the heart emoji, which I guess you can figure out by looking, right? All of those 3 people, you totally can go to the portal under, in Google Classroom that says multiplayer co-op, and each one of you could go in, like just screenshot that right now from the chat. I mean, you don't have to do it now, but yes, screenshot it now. And then tonight or whatever, or next week, it doesn't have to be by midnight tonight. When you remember and feel like it, just type into multiplayer co-op. Like I helped Judith when she asked, what is X naught? I mean, be specific. Remind me specifically what happened. But and the screenshot will help. And each one of you, including Judith, will get points for like publicly helping out each other in the class. I'm serious. And I won't re-explain it every time, but I want you to know that's how it works. And if you do it again tomorrow, you go to the same portal or next class and submit again okay, that's how that works. Okay, thank you. Okay. And that includes the okie dokie, thank you, etc. All right. So, but I assume that means my handwriting is terrible. So let me do. All these game portals, all the whole fact that like you get points for all these different things, but that you have to actually submit to get the points, for what it's worth, like this gamification is brought to you, as far as I'm concerned, by Animal Crossing. Like the whole thing is based on the idea of Nook miles in Animal Crossing. And I'm just like trying to be like Tom Nook. For those of you who know what I'm talking about, I'm glad. For those of you who don't know what I'm talking about, don't worry about it. I mean, it's just a side reference, but that's where all this came from, is like me years ago, like wanting to be like Tom. And don't get me wrong too. I think he's a total ripoff con artist. Uh, but one of your other physics professors thinks he's like the greatest genius capitalist in the world. So, he takes all kinds. Okay. Don't be a Tom. I know. I don't actually like Tom. Right. Okay. I don't actually like him, but I do sort of admire him. Anyway. All right. All right. All right. Okay. 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 So that's, I mean, he makes a lot of money for like a rodent, but okay. All right. Oh, all right. So that's excellent. So then here's a weird thing. So I just said like any symbol sub-zero would equal the value of that symbol when t equals zero, right? So then what does that mean? Here's like this like a weird thing. What does that mean about t naught? According to this definition, t naught would equal the value of t when t equals zero, right? I mean, literally, something naught means the value of it when t equals zero. So t naught would equal t. In other words, t naught would equal the initial time, right? So that must always be zero. The value of t when t is zero is always zero. I hope you see what I'm saying. Like that's not true for x or v. X naught might be 4, v naught might be -7, but t naught for sure is always zero by definition. So what is that? What is t naught equals zero? I mean, when we say t equals zero, do we mean the Big Bang? Do we mean the Garden of Eden? No, we don't. We don't mean either one. And I'm not making fun of either one. Both of those are very legitimate, like whatever things to think about. But when we say t equals zero, we don't mean the beginning of all time. When we say t equals zero in a physics class, what we mean is what t equals zero really mean. That's not legible. What t equals zero means is when the researcher, the physicist, the problem solver, the observer, okay, whoever, same thing, when the scientist started paying attention to the phenomenon, when the scientist started his or her stopwatch. And I mean this very literally, because the whole idea, it's an important way to think about physics is experiments don't start or stop. Phenomena don't start or stop. The universe is just flowing all the time, right? And what we're doing is entering into the universe and taking measurements from the universe to suit our needs, right? So even this idea, even this fate, and this is how we think of the lab as well. Things are happening in the lab, and then we decide to take a chunk of measurements to study, in the lab. So even this instructor that is a fake experiment, I mean, it's a thought experiment, but it's an experiment. This instructor, the idea is not really that the instructor started at the 4 meter mark and then like did a bunch of stuff. It's that the instructor is just like going back and forth and doing his or her own thing for forever, as far as I'm concerned. And then we walk in, we start paying attention. We start our stopwatch at a certain moment. That moment is t equals zero. It happens that at that moment when we started the stopwatch, we took a measurement and caught a glimpse of the instructor being at the 4 meter mark. And so from here on in, we take measurements. T equals zero means literally when your stopwatch started. Okay. Just like, by the way, X equals zero means wherever you decided to put the center of your meter stick before the whole experiment began. Okay. It's up to the observer. And we're going to say a lot more about that like very soon, but that's the case. Okay, just looking. Oh, isn't he a debt? Oh my God, what? Oh my God. Yeah, yeah. Tom Nook is totally a debt collector. Yes. Okay, and this is all a sidebar. If Tom Nook is from a video game, the video game's called Animal Crossing. I'm just joking around about it just to like be silly and keep you awake. But I promise you, if you know the video game, great. I feel bonded to you, or whatever. But if you don't know the video game or you don't like video games, I promise that is not a prerequisite for the class. Like calculus is a prerequisite for the class. Video games are not. Um, but they help. Okay, all right. So moving on. Don't even get me started about Pokemon. Okay, moving on. Uh, there's a math. Yeah, I see the chat is like lighting up. Can you get points for participation for chatting about things that are off the topic like me? Yes, you can. As long as we're staying awake, it's good. Um, but I just don't want there to be any, I just don't want you to think that you have to be part of that discussion. All right, moving on. So t equals 0, x equals 0. Okay, so now, and what time is it? Okay, we have to, and obviously I want to get back and start getting answers, but we're almost there. Now that we've established x, x naught, t naught, we're almost at the point where we can put these things together and have some equations, right? For example, from here on in, x minus x naught okay, I mean, this is still not quite an equation, but let's make it clear now. The if x is where something is at any moment. Again, so I'll call that final position. I don't mean like the final position at the end of the universe, or I don't mean like the final four at the end of the basketball tournament, or what. I don't know what that means either, but like what I mean is the final position at the end of some segment of space and time that you were paying attention to and calling an experiment, right? It's up to the researcher, up to the physicist to decide what they're paying attention to. But any value so they start paying attention somewhere and may make a position measurement, call that x naught. Then they stop paying attention somewhere else, call that x. So the difference between the final x and the initial x is how much the object got displaced. Like literally the difference between the final place and the initial place is how far the object got displaced. Um, and and it might even look different. It might even look like a little backwards to you. I'll say this really quickly. You might be thinking, wait, but why is it final minus initial? Like, isn't that going backwards in time or something? Well, that's the way subtraction works, right? Like literally, if I want to know how much you've grown in height in the last 7 months, right? From like, whoa, I haven't seen you for 7 months. I haven't seen you for 2 semesters. You look so much taller, right? And you're like, yeah, actually, I grew 6 inches in the last 7 months, or whatever. Like, what? How would you prove that to me? You would say, right now, I'm 5'6", and 7 months ago, I was 5 feet. 5'6" minus 5 feet equals 6 inches. You know what I'm saying? Like, that's how you do subtraction. And subtraction means difference. I think you get my point. So notice position is a measurement that we take at a point in space. The difference, but the segment, the interval between 2 points in space, the comparison between 2 points in space, that's what we mean by displacement. So displacement is different from position, right? It's a comparison of two positions. Displacement from here on in is x minus x naught. Last quick thing about that. If you've taken physics before in high school or whatever, or you look these things up in textbooks, you might used to be calling it x2 minus x1 or xf minus xi, like x final minus x initial. That's all They all mean the same thing. Use whatever symbols you're comfortable with, as long as you're clear that they all mean the same thing. But I use these symbols. So, we're almost there. So, is there anything else I'm missing? Okay. Okay, so we're almost done with like this level of notation, but just to get it all out on the table, from now on, if I have any letter and I put it down and I put a bar above the letter, like a horizontal line, then that means the average value of that letter, of that variable, like for any variable. Okay, so why am I saying that? Therefore, from now on, so from now on, the letter V is going to be used for velocity. V with a bar over it, therefore, will mean average velocity. And if you want to know, well, what does average velocity mean? I mean, you see where this is going. From now on, oops, average velocity will be defined to be the displacement, the difference between two positions that occur between two corresponding values of time. From now on, average velocity is displacement per time. And that means the displacement that occurs in some corresponding interval of time, like not some random interval of time. And since we already said that T naught always has to be equal to zero, like X naught does not always have to be equal to zero, but T naught does, right? Since T naught is always equal to zero, if you want your first memorizer or your first equation from the class, for this class, I'm going to, so this is our first equation, right? Hopefully it doesn't freak you out. Hopefully it makes sense. Let's talk about it. It's the only equation we have so far. I'm going to start again. I know we have 11 minutes. I'm going to start going back and like getting the answers for the rest of the things on the homework. But I want to say a couple of things about this. This is our first equation. This is our only equation. This is like the only equation that I'm going to feel like it's legal to use for a little while. You were able to do the homework without having this equation, I believe. Most of you, right? I believe a lot of you got a lot of correct answers on the homework, even before we'd established this equation. And even if you've seen this equation somewhere like in high school, that doesn't mean you had to have used it in order to get the homework right, probably. Why is that? Because this equation makes sense, I think. It's really, you can memorize it, but honestly, I think you'll accidentally memorize it without trying because it actually just makes sense. When was this equation discovered? Never. When will it ever possibly be discovered to be wrong or limited or have exceptions? Never. Why? Because it's not a discovery, right? It's just a definition. We are just saying from now on what we mean by the average velocity of some object from now till later is how far it gets, say in meters, per how much time it took to get there, say in seconds, right? It's literally just a definition, a shorthand. Average velocity is for displacement per time. Now, and I should say also similarly, oh, it is like as a sidebar, it's based on the English idea that average speed is distance per time, right? Distance is a scalar, speed is a scalar. Average speed, your average speed is defined to be how far you get per how much time. Notice that's an equation too. It just is like written in English. What tends to happen at this stage of physics is the simpler ideas, the scalar ideas that we sort of already are holding in our head before we even walk into a class, we're still holding on to those and we're building everything off those. And we're leaving those in English because we want to emphasize that they make sense and we knew them even without physics. But then we're building from the scalar quantities, these vector quantities. We're going to get more precise and more detailed. So we make up the symbols and the equations to apply generally to the vector quantities. Okay, like it's not a coincidence, in other words, that in the 8 minutes that I have left, any answers that I'm getting about scalar things, I'll probably continue to think through and write in English. But the more I'm getting into the precise stuff, the more I'm going to use symbols and equations to capture it. Okay. So our one and only one equation so far is that average velocity is defined to be displacement per time, like that yellow equation right there. And last thing on this, now start getting answers. Last thing, if you're thinking anything like, wait, didn't we skip a step? Like you just defined average velocity, but did you ever, Yaverbound, did you ever like just define like velocity, like V without a bar over it? If you notice that, if that even slightly bothered you, even half unconsciously bothered you, good, you're correct. But I'm also correct. We did not yet define V by itself. That's not an accident, but that is confusing. We have all we've defined so far here, and all we have an equation for is the average velocity between here and there, or between now and later. That's all we know right now. In other words, to give a quick, we'll do the example. But in other words, if you know for a fact that something went from the +4 mark to the -5 mark in 8 seconds, then you know for a fact that its average velocity for that experiment is -9/8 feet per second. And that's what you know, that on average, it's going that fast. Do you know how fast it's going or what direction it's going at any given moment? Not yet. No. Turns out that the reason we haven't defined that yet is because that's harder. It's harder to pin down. This one's easier to conceptualize and understand, like for all of us. So we invented or discovered this idea first. Okay. So we don't yet have a notion for velocity like at a moment, but we do have a notion for velocity on average. Okay, we have 6 minutes. When I'm gonna, oh, sorry, there's my, I like Pokemon. Okay, I'm just looking at the chat. All right, so we have like 6 minutes. What I'm gonna do in the 6 minutes is bang through some more answers just so we can see if we're on the same page. As long as you, wait, is Brittany in this class? Sorry, I can never tell when it's 12. If someone's in the waiting room, if it means they got kicked out or if it's from the next class. Wait, sorry, can someone quickly tell me in the chat, is there a person named Brittany that is in this class? Or is that from the next? I'm going to assume no, unless someone tells me if, oh, yes. Yes, Brittany is in this class. All right. Oh, yeah. All right. Thank you. All right. So she got kicked out. Okay. Thank you. Thank you. Oh, that's all multiplayer co-op, by the way. All of you. Seriously. Emily, Colin, Nasreen, thank you. All right. So we've got 5 minutes. What I'm going to do is give answers now. And make a note if you don't like one of the answers or you're unclear, there might not be time to ask a question about it today. But the first thing we'll do when we go back to class on Monday is like ask a question about it. Okay. And again, and I'm going to put the answers now. This is not the work, this is just answers. But the other thing is, please remember, as long as you did a draft of Numberline in time for Monday, then anything I'm saying in this class that helps you fix things or improve them you can go back and revise and re-upload and get more points. I mean, I think that's clear, but I hope that's clear. So bear with me. So I'm just going to give answers now so you know what's going on. Where did the sheet go? Hold on. I know we only have 5 minutes. Okay. All right. So we did question 1 and 2, right? Okay. So question 3. Oh yeah. All right. So oh yeah. Okay. Okay. So the average feet, again, these are just answers. So just make a note, or if you don't like one. So the average speed for the entire 8-second journey is 21 feet over 8 seconds. It's a stupid number, but it is the number. That would be the answer. Can you express that way? Yes, you can. Or can you make it into a fraction? I mean, a decimal? Yes, you can. That would be 2. Oh my God. Is it 2 point? Okay, I'm losing my mind. Wait, 2 point, yeah, 2.6. And I'm just going to 3 significant digits, right? Stop me if that's wrong, but I believe that's right. So that would be the answer for that. You could express it either way, is what I'm saying. Is it 2.68? In the chat. Yeah. Thanks. And yes, I'm sorry. Also, there's things that 6.2. Oh, 6.25. Sorry. Okay. Really? Yeah, you're right. Sorry. Oh, 0.6. I got it. Yeah. Sorry. You're right. So I'm rounding. So I'm doing to 3 significant digits. I'm rounding to 3. But yes, thank you. Also, very quickly, because I know we're running out of time. Someone just asked, but thank you guys. That is multiplayer co-op too, or whatever. Yes. Like I will. Then from here, I'll proceed to going over homework too. And we'll like catch up with ourselves again at the beginning of this semester. I'm like trying to lay out a lot of concepts, so like I fall behind. But yes, I will go over homework 2 next. I mean, it will be a while before there's any problem in a homework that I skip or don't go over. I'm going to go over all of these things at the beginning. Yes, someone's asking, but I also want to warn you, good point, even though there's only 2 more minutes. The way it will always go in physics is you have to think about the homework before I go over it, not the other way around. Like it's not like I lecture and then you figure things out. You try to figure things out, then I explain them. But that's why then you have time to go back and revise and get all the points. Okay. But yes, you're always going to be asked to think about things before I explain it because that's the nature of physics. The next thing should always be figure outable from the last thing. All right, I'm sorry. Oh yeah, wait, sorry. Okay. Um, there's another good question. And if you resubmit something and if it marks it as late because you resubmitted, right, that's not an issue. As long as if I can see if there's already points there, I'll know that, right. When you resubmit, I guess it does sometimes. I feel like there's a way of avoiding that. But if you're resubmitting and it's saying it's late, it's not. Don't worry about that. And if there's a way I can fix that, I will. All right, very quickly, like let me just give you a couple more answers just for now. Just so you have, so question 4, what's the average velocity? The average velocity is -9 over 8 feet per second, which is to say, and it's negative, right? It is negative, which is to say negative 1.125, which we could say 13 feet per second. And don't worry about that. If you do different significant digits or you round it differently, don't worry about that's fine. Question 5, what's the average speed for the first 5 seconds of the journey? Well, the first 5 seconds, he goes, uh, uh, it's 12, yeah. Okay. Average speed equals 12 feet per 5 seconds, right? In other words, sorry, 2.4 feet per second. That's the average speed. I'll do one more and then we'll stop. And question 6, what is this nonsense? Question 6, what's the average velocity for the first 5 seconds? The average velocity for the first 5 seconds is 0, right? Because he ends up where he started. The total displacement is 0. So that's sort of interesting. The average velocity for any round trip is always 0. We'll end on that. I know we're 1 minute overtime. You've been very patient. keep on rocking the free world. I'll catch up with you. I'll see you Monday. Oh, sorry. Oh, thank you for the class. Okay, your computer's went. Yes, thank you. I'm going to stop the recording. Have a great day. If you want to hang out for